Okay, we're going to work on homework chapter 3.1, 3.2, 3, and 4. All right, so question number 1. Find A, any critical value, and B, any relative extrema. So first of all, what is, let's understand real quick, what is critical value? Critical value is, let's say if I show on the graph, maximum, minimum, those are critical values. See, this is critical value. That's maximum. Then it can be this one. This is going to be minimum critical value. Okay? So what is interesting about critical value, in the point of critical value where horizontal line is equal 0, that means the derivative at this point is also either 0 or doesn't exist. When it won't exist, if when you have graph like that, okay, because it's not a function, so f prime of this seed won't exist. Okay, so first we are going to do how to find a critical value, and after that we will learn how to figure out relative extreme. Okay, so we have x squared plus 8x plus 10. X squared plus 8x and plus 10. So to find the critical value, I'm going to take derivative. So f prime of x is going to be equal. X squared is going to be 2x, right? To remind you real quick formula, derivative of x to power n. Wow, it's quite thick. Hold on. X to power n is equal n times x to power n minus 1. So since I have here square, so 2 come in front and 2 minus 1 is 1. Plus 8, here will be left only 8 because you have here 1 and 1 minus 1 is 0, right? And here will be 0. Derivative of constant is 0. So like I said, in the point of critical value, derivative is going to be either 0 or won't exist. So we find derivative. Now we need to find the critical value. We need to assign it to 0. To x plus 8 is equal 0. From here to x is equal negative 8. And x is equal negative 4. And this is our critical value. So let's put in there, check it. So negative 4. Bingo. So now question B, it's going to be find any relative extrema. So first of that, because we found our critical value 5, and it doesn't have to be only one critical value. It can be much more critical values. But in this example, we have only one critical value. So we're going to explore that critical value and figure out if this is minimum or this is maximum. Okay? So select the correct choice below, and if necessary, fill in the answer box within your choice. So I'm not reading all this because it's already for question B. It says find any relative extrema at the beginning of the whole problem. So let's find this at the negative 4 what it is. Is it minimum or maximum? And then we will find the answer accordingly. So what do we have to do? First of all, we are going to here mark down our critical value. It's negative 4. Let's assume this is negative 4, which means, for example, 0 is here, plus is here, and minus is here, right? So we have, this negative 4 is breaking down into two pieces. This piece and this piece. Okay, so what am I going to do? I'm going to test and see if my x is equal -4. I'm going to take any number from this area that is less than -4, and then take any number from this area where x is greater than -4. So, and then we'll see. I will let you know why we are doing. So I'm going to test and see f of x is positive or negative, and then I'll explain. Okay, since I mentioned it, let me tell you. Let's say this is my -4, right? My x. So everything is so thick. There we go. So this is -4. If I find, because I don't see the graph, if I would see the graph, I would say, yes, this is minimum. But I don't have the graph, I don't see the graph. So I'm going to take any number here from -4 and below, let's say -5, -6, and so on. And if f of x is negative here, okay, if f prime of x is negative, I get is less than 0 or negative, and here I get f of x is greater than 0, then I can see I'm moving from negative to positive, which means I'm having minimum. But if I have -4 like this, and here I have f prime of x greater than 0, which is positive, and here I have f prime of x less than 0, which is negative. So from positive to get negative, I have to go up and go down, right? Because this will be negative, dropping, and this is positive, is going up, and this is down. That's what I'm going to do. I'm going to take some testing number less than -4 and then greater than -4, and see if we are getting positive or negative. So let's assume less than -4. I'm going to take -5, for example. Yeah? So f prime of -5 is going to be, so I'm testing this piece, right? This is my derivative. 2 times -5 plus 8. And it's equal -10 plus 8 is -2. So this is going to be negative. Now taking positive side, this side. For this side, I'm taking 0 because it's to the right. So f prime of 0 is equal 2 times 0 and plus 8, which is equal +8. So, let me see. In this case, I have to the left, I have negative. To the right, I have positive. So from negative to positive, that means it's minimum, right? So it is going to be minimum. All right, so -4, x is equal -4 is minimum. Well, let's see now which f of x, which y, it's gonna match to -4. For that one, I'm going to plug my -4 to original one, because minimum, maximum we are finding from original problem, right? So we have f of x, that is equal x squared plus 8x plus 20. So I'm going to plug. I want to know how much will be y for -4. It's going to be -4 squared plus 8 times -4 and plus 20. So I'm getting 16 minus 32 plus 20. This is going to be -16, and plus 20 is equal +4. So the relative minimum is in the point. First goes x, -4, and second goes y, which is positive 4. And that is going to be our answer. So remember one thing. If you want to find a critical value, you're going to get a derivative, and critical value is you can find in the point where where derivative is 0 or doesn't exist. Therefore, to find critical value, we have to find derivative and plug x as a 0 in the point of critical value. But to find the maximum, if once we find maximum or minimum, if we want to find the pair of that x, meaning how much the y is for that x, then we are plugging into original f of x, not derivative. Okay? See, this is our derivative. We use derivative to find critical value, but to find the f of x, meaning y, for given the critical value of x, we are using original function. Don't forget that. Don't get confused. Okay? So let's go see what it's going to be our choice of answer. So select B. Select correct choice below, and if necessary, fill in the answer boxes with the choice. So we know that in our case, it was relative minimum, which means it's going to be either A or C, right? That's where it's talking about relative minimum. The relative minimum point is R, let's say -4, +4, and there are no relative maximum. That's a good answer. That's fit to our the solution. So we plug here, and where is our parentheses? Let me see if I can find. Oh, here it is, parentheses. So we have -4, 4, comma, +4, and we close parentheses, and it's going to be this. What? We had -4, +4, right? Let me see. Yeah. So I'm curious what is happening. And we don't have relative maximum, obviously. Let's double check. Maybe I did some silly mistake, so I'm also a human being. Let's double check. So we took the value -5, right? So we plugged 2 times -5 is negative here, -10. -10 plus 8 is -2. So it's negative. Okay, and to the right side of the -4, I'm taking the 0. So 2 times 0 is 0. And plus 8, it's going to be 8 positive. Yes? Okay, so all is good. So -4 is minimum. Now let's check also how we plugged -4. -4 squared is going to be 16. 8 times -4 is -32 and 20. 16, -16 plus 20, +4. All is good. Let's go back and check. And that was minimum because it's changing from negative to plus. That means we have minimum. From plus to minus, let me show one more time. From minus to plus, that looks minimum. Right? Here we have minus, and then here we have plus. But if we would have plus and then going minus, then it would be maximum. So everything is all right. Let's check. Relative minimum, -4, +4. Could it be? This is space I not need to push. No. Well, okay. I'm going to get final answer. I'm curious. All right. I want to see what answer is going to be. -4, -6. How is it possible? Oh, x squared plus, oh, hold on. Wow. See, silly mistake. Instead of plus 10, I put here plus 20. Okay, well, at least you know correct answer. So how to solve it, I mean, let me see, -16 plus, it's gonna be 10. Ugh. So if I put here, I don't know where from I got 20, plus 10, okay. And once we put plus 10, it's gonna be -6, okay. I'm not going to solve similar because next problem also gonna be something like this. Plus, you know how to solve it. It just, I put 20 instead of 10. I don't know why. Well, math and silly mistakes go hand by hand. All right, so we are good with this. Moving to next question. Let's see what we have here. So same problem, find critical value and find relative extrema. It's either relative minimum or relative maximum. So we have negative x cubed this is question number 2. Negative x cubed plus 27x minus 63, okay? Plus 27x minus 63. Okay, so what we are going to do, first thing, we need to find the critical value. To find critical value, we need to take derivative, right? And then assign derivative to 0 and find the x from there, correct? So let's take a derivative. F prime of x is equal -3x squared. Well, I'm not going to write the formula every time. Plus here will be 27, and that's it. So next they are assigning -3x squared plus 27, which is equal 0. So 3x squared equal -27. X squared is equal -9. Let me see it. I will check one more time. I'm afraid. Yeah. Okay. And we are getting -3. Oh, see here again, minus. So negative x squared equal -9, which means if I divide by -1, both sides, right? Let's say -1 here and -1 here. And I'm getting x squared equal 9. And from here, x is equal plus minus 3. So in this case, we have two critical points, -3, +3. Let's plug. Plus, minus, and 3. Okay, so we are sure we have critical value correct. Now we need to find this critical value, each one of them. Is it relative maximum or relative minimum? Let's work on it. So what we are doing, here we have -3, here we have +3. Yes? Okay. So we are going to take, it's divided into 3 pieces, yes? One piece, the other piece, and third piece. No, 0 somewhere here. This is, we have negative infinity. Here we have positive infinity. So we have to test all these three parts, okay, intervals. So less than -3, which number I want to take? Let's say -4. I'm taking here -4. Between -3, +3, I will take 0. And more than the 3, I will take +4. And let's see what we are getting here. So, f primes, since we want to know we have relative maximum or minimum, we are going to work with derivative, correct? So I'm going to test derivative for -4, for 0, and +4. So f prime of -4, so we have our derivative is -3x squared plus 27. So I'm going to plug -3 times -4 squared plus 27. So this is going to be equal -3 times 16 and plus 27, -48 and plus 27. We are going to get -21. So on this side, we have negative. Okay, now we are testing 0. F of 0. Let me see if I can squeeze in and bring here. Yeah, not working well. Now f of 0. Testing, this is on interval negative. On interval -infinity and -3. Now I'm testing on interval -3, +3. So 0, I'm taking 0. F of 0 is equal. Where is our, here it is. Let me move it down so we will have it. Okay, here it is. So I'm plugging -3 times 0 squared and plus 27. So this is 0, we are getting 27, which means on this interval we are getting positive. So here we get negative and then positive. So -3 is going to be our relative minimum, right? So now we are checking this between -3 and +3, we are positive. Let's see what we're going to have above 3. So 4, we are taking 4. So on interval between +3 and positive infinity, we are taking f of 4. And that's equal, so -3x squared, 4 squared, and plus 27. It's going to be the same -21, right? Because we are squaring, so it doesn't matter. -4 or +4. So which means we are getting here negative. So look on this side, we are getting from positive to negative. It's going to be positive and then negative. So +3 is going to be relative maximum. Okay? So once we have relative minimum, relative maximum, let's find the y that matches to -3 and matches to +3. So I am plugging f minimum of -3, right? Our -3 is minimum, is equal. Where is our original here? -x cubed. So it's going to be equal -3 cubed plus 27 times -3 and minus 63. Okay? and f of positive 3, which is going to be maximum. We want to find the y that matches to that negative 3 and positive 3. It's going to be negative positive 3 cubed plus 27 times positive 3 and minus 63. So what do we get in this one? So negative 3 cubed, let me use different color. Negative 3 cubed going to be negative 27. Oops. So it's going to be negative, and here negative 27 minus 27 times negative 3, 6, negative 81, and negative 63. So negative 27 is going to be positive 27, right? So we are going to get 27 minus 81 minus 63. How much we are going to get? Let me see. 27 minus 81, it's going to be negative 54. Negative 54 and negative 63, we end up adding. So it's going to be negative 117. So for negative 3, for our minimum, it's going to be negative 3, negative 117. Now let's say for our maximum, how much it's going to be? It's going to be negative 27, 3 cubed. 3 times 3 times 3. And then plus 81 and minus 63. Okay, so 81 minus 27, it's going to be 54. One second. Okay, 54, positive 54, and then minus 63, it's going to be negative 9. So here we have positive 3 and negative 9. Okay, so this one is going to be coordinate of minimum. This is going to be coordinate of relative maximum. Let's plug the answer, see what we have. All right, so what do we have here? We need the relative, we need the statement with 2 spots where we have to place the answer, because we have nth minimum and maximum, which means B, C, and D falling out right away, because there are only one frame, one window for entering answer, which means our answer is going to be A. Let's read it and justify if that's the case. Relative minimum point is, okay, we'll place the answer, and the relative maximum, yeah, that's correct. So relative minimum is going to be negative 3, negative 117. So negative 3, comma, negative 117. Okay. And the other one, and this one is going to be what we have here. Negative, positive 3, negative 9. Okay. Three, comma, negative 9. And we are closing. Bingo. Moving next one. So here again we have to find critical value and any relative extrema. Let's try to work out again real quick. It's gonna be easier this time, right? Okay. So we have x squared plus 10x minus 7, or x cubed plus 10x minus 7. Double check. Yes. So derivative, this is number 3. Derivative is going to be 3x squared plus 10. So this is our derivative. Now to find critical value, I'm assigning to 0. All right. And we are getting 3x squared equal negative 10, and dividing by 3 on both sides. And we are getting x squared is equal negative 10 over 3. Okay, so in this case we have, if x squared is negative number, that means no real solution, right? Okay, so if it's no solution, because square cannot be equal negative number, that means there is no critical value. Let's find it. Has no critical value. Okay. Bingo. And next we need to find any relative extrema. If there is no critical value, that means no relative extrema, right? So this is going to be this one. No relative minimum point and there are no relative maximum point. Neither one of them. Very good. Moving to next question. Question number 4. Okay, let's see what we have here. So, find any relative extrema of the function. List each extremum along the x value at which it occurs. Identify interval over which the function is increasing or it is decreasing. Sketch the graph. Okay, let's figure it out. So, we need to find relative extrema. Our question is 7 minus 4x plus x squared. Number 4. Seven minus 4x plus x squared. Let me rewrite it. Okay. So let's take derivative to find critical value before we be able to identify relative maximum, relative minimum. It's going to be 2x minus 4. Then we assign to 0. 2x is equal 4. X is equal 2. Was it x squared? Let me check one more time. Yes. All right. Two x minus 4. 2x minus 4 equals 0. All right, so all is good. So x is equal to is our critical value, right? Okay, let me see. Do we have the question to answer? Ah, no. It wants straight the coordinate. Okay, well, we can do it. It's not a big deal. So once we got a critical value, all we have to do, this critical value, plug to original equation, which is this one, right? And see which y is matching to that x is equal to. So f of 2 is going to be equal 7 minus 4 times 2 and plus 2 squared. Yes? So this is going to be equal 7 minus 8 and plus 4. 7 minus 8 is negative 1. Negative 1 plus 4 is 3. So our coordinate is going to be 2 and 3. Coordinate for critical value. Now, to find if it's a maximum and minimum, okay? So, this is our 2. So, negative, positive part, negative infinity, positive infinity. So, it's breaking into 2 intervals, right? Where I'm taking number from here, it's going to be, I can take 0 here. And on this side, I can take 3. Okay, so f of 0, it's going to be f prime of 0. It's going to be, where is my 2x minus 4? It's going to be 2 times 0 minus 4. I'm looking here. And the answer is going to be negative 4. So that means it's negative. F prime of 0 is decreasing, negative. Now let's take point 3. F prime of 3 is equal 2 times 3. Here is the derivative. Two times 3 and minus 4. And it's going to be equal 6 minus 4 is 2, positive. So we are going from negative, falling down, to positive. So negative is dropping and positive is rising. So we are dealing with relative minimum. So we have a relative minimum with coordinate 2 and 3. And we have only one coordinate, right? Not 2. We set minimum, so the relative minimum, B is not going to work because it has maximum also. It's not our case. We have only one minimum. This is going to be C. Two, comma, 3, closing parenthesis. Bingo. Oh, we have also something. Okay, identify which interval over which the function is increasing or decreasing. Well, we already identified, so on interval negative infinity to 2, it's decreasing, right? F prime of x is, because it's negative, is decreasing, negative less than 0. And from 2 to positive infinity, we have plus. That means is increasing. So negative infinity 2, let's see. we need two windows for windows is for answer, which is looks like C. Let's see. The function is increasing over interval, and it's going to be 2 and infinity, right? 2, comma, where is that infinity? Now go find it. Oh, here it is. And closing. So it's rising, right? And decreasing over negative infinity. And 2. Okay? And checking the answer. Well done. Now we need to graph or choose which graph it is. So 2 is going to be our critical point, and 2 was our minimum. So we need to find the graph that is going up, right? Not going down, because look, if we decided that it's our minimum, if this is minimum, right? That means graph is going to go like this, correct? Okay. Well, let's see which one it is. So it's going to be either A or C. Both of them are going up. Now let's look if the vertex, which is main minimum, is going to be in the point of 2. Oh, A is in the point of negative 2, so it's not working. That means it's going to be B in the point of positive 2, right? Oh, here it is, it's positive 2, and from negative infinity, when x is negative infinity, between negative infinity and 2, graph is going down, is negative, and behind of 2, its graph is increasing. So that is the case we are choosing C. Number 5. We don't need to show work. We are going to question number 5. So for the graph shown, identify the point of inflection. We need to find which points are representing inflection, and the interval where the function is concave up or concave down. Okay, so points of inflection occur, let me zoom this so we can see, occur where the concavity changes, and it identify where the function might be concave up or concave down. So in this case, let's see, we need to identify relative extremum, which is going to be either minimum or it's going to be relative maximum. So let's identify on this graph. We see that we have relative minimum, graph already tell us, and that is in the point 0 and 1, right? So let me draw this graph. So if this is 1, this point is going to be our minimum, 0 and 1, correct? Relative minimum. Okay, and at this point it's going to be relative maximum. Let's see which how much it is. it's going to be at the point x is equal 2 and y is equal 1, 2, 3. Let me show you here. So this is 2 and this point is 3. At the point 2 and 3, we are going to have relative maximum. Therefore, this function is concave up on some interval. So what do we have? We have that our inflection point is here between 0 and 3. Between 0 and 2 is going to be 1. 1 is x is 1 and y is 2, I would say. 1 and 2, yeah, we already have it there, that's the case. So this is going to be 1 and 2, which means from an interval from negative infinity to 1, we have concaving up. From negative infinity to 1. Concaving up. But from 1 to positive infinity, concaving down. Look. This is concaving up, this is concaving down. Therefore, this piece concaving up from negative infinity till 1. And from here to here, it's going down. So let's place the answer. So it's going to be from negative infinity. Oh. Okay, let me clean everything. Comma 1. Was it 1 or 2? I think 1, yeah. Closing parenthesis. Okay, and 1 and positive infinity. Concaving down, let's check.